Section 3.1 talks about quadratic functions and models. So what we have here in this green box is something called the graph of a quadratic function. And it says the quadratic function f of x equals ax squared plus bx plus c can be written in this form here. This is often what we call vertex form, guys, okay? So let me just make a little note of that. This is what we call the vertex. Oops. There we go. Vertex form. So y equals f of x times a, and then quantity x minus h squared plus k. It tells me here that a is not 0. Okay, so the number a won't be 0. The way I'm going to find the h value is we're going to take the negative of b over 2a, and the way we're going to find the k value is whatever number we get here, we're going to come back and plug it into the original function, and that's how we'll get the k value. So it says the graph of f has the following characteristics. It's a parabola with the vertex being the point hk. So we talked about vertexes with circles, or the center of the circle. The vertex of a parabola, all our parabolas, guys, are going to look something like this. They're either going to open upward or, oh, come on, pen. Or they're going to open downward, okay? The vertex is going to be, hold on, guys, my pen is freezing up a little bit here. There you go. The vertex is either going to be the lowest point of the graph or the highest point of the graph, okay? And then we have something called the vertical line. It's going to be this line of symmetry. It's going to be the line that cuts the graph directly in half, okay? It tells you the graph's going to open upward if my number a is greater than 0. That just means that my number a is positive, and the graph will open downward if a is less than 0, meaning a is negative, okay? So here, a is positive, and in here, a is negative, okay? It says it is wider if the graph it is wider than the graph of y equals x squared if a is, the absolute value of a is less than 1, and narrower if the absolute value of a is bigger than 1, okay? The y-intercept is always going to be the point 0 and c, right here. And we're going to talk about x-intercepts. So it'll say the x-intercepts are found by solving this equation right here. We can do this using the quadratic equation. This part right here, b squared minus 4ac. If this number here, that's the number, we call this the discriminant. Okay, the discriminant. It just says that the discriminant is positive, then these will be my x-intercepts. We'll have 2. If the discriminant is equal to 0, we only have 1 x-intercept. And if the discriminant is negative, then we don't have any x-intercepts at all. Okay, so the first problem here says match the equation in 1 with the description in 2. All right, so just so that we know what it is we're looking at, f of x equals a x minus h squared plus k, where my vertex is the point h and k. Okay, I want you to notice something here. See how we have a minus here? Here we just have a plus. This is a plus k, this is also a plus k. All right, so remember, when a is positive, the graph opens up, and when a is negative, the graph opens down. So if I look at this first one here, that's telling me that my vertex is going to be the point -4, because I have to change this sign, because we changed it from here to here. This one stays the same, +2. Since the number a is the number right here, since that's positive, my graph is going to open up. So I'm going to say, okay, which one of those has a vertex of -4, 2, and opens up? C. So this one here is going to go to C. Okay. Now, let me take a look at the next one. So I'm going to look at this one here now. Okay. So when I look at that one, the vertex on this one, it's going to be the point, I'm going to change the sign, -2. This one stays the same, +4. And my number A is still positive, so my graph is still opening up. Okay, so -2, +4 opening up. That one there is going to go with this one. Okay. All right. Now, let me look at the third one. So my vertex here, remember, I'm going to change the sign. So my vertex here is going to be a -4, a +2. My A is negative. So my graph's going to open down. So I'm going to look for a vertex of -4, 2, and opening down. This one is going to be matched up with D. And then we have one more. It's got to be B, right? Just by process of elimination. But again, on this one here, let's just go through it. So my vertex, remember, I'm changing that sign, -2. Leave this one alone, +4. A is negative. So again, my graph opens down. And so that one gets matched up with B. Okay. All right. So let me scroll down. And I'm going to take a look at this next problem here. And it says, consider the graph of each quadratic function. Part A says, give the domain and range. Okay, so let's do that part. So the domain. Guys, the domain is the set of the x values. So again, just remember what I mean by the x values. I'm looking at my number line here. So obviously if I were to go down, I'm going to hit my graph. And obviously if I go up right here, I'm going to hit my graph. But because this graph has these arrows going on forever and ever, all that means is that no matter how far to the left I were to go, if I were to go up, at some point I would hit that graph. Same thing if I were to go to the right. If I were to go up, at some point, you know, that graph's going to keep going up and up and up. So at some point I'm going to hit that graph. So just so that you know, the domain is going to be everything from -infinity to +infinity, right? All real numbers. No matter what number I pick on the x-axis, I can either go up or I can go down, or I might even stay right there, but I'll hit the graph, okay? Oops, let me get the eraser here. All right, now let's find the range. Now remember what the range refers to. The range refers to the y values, okay? So I'm going to take a look at my y values. Here's my y-axis. The lowest y value we hit is right here at -4. But as long as I go up, then when I go to the left, I'll hit my graph, or, you know, this graph's going to go this way, so at point, I might have to go to the right. But the lowest point we have is from -4. Oops. Oh, come on, pen. There we go. From -4 to infinity, right? So we might say y is bigger than or equal to -4. Okay. That would be my range. All right. So again, just so we have an idea of what the domain and what the range are. Now let's do part B. Part B says give the coordinates of the vertex. Okay, so when I look at my graph here, remember, I'm going to change this value, -3, that one stays the same, +4. Okay. Part C says give the equation of the axis. They're talking about the axis of symmetry. What they mean is the line that cuts the graph in half. If you can see, it cuts it right in half when x is equal to -3. Okay. All right. Now part D says, let's find the y-intercept. Guys, the way I find the y-intercept is I'm going to find the value f of 0. So I'm going to come back to my equation right here, and everywhere I have the letter x, I'm going to put the number 0. Okay. So 0 plus 3 is still 3, squared minus 4. 3 squared is 9. 9 minus 4 is 5. So part D, the y-intercept is going to be the point 0, 5. Okay. And then there is a part E, so let's do it. Part E says we're going to find the x-intercepts. The x-intercepts just means where does it hit the x-axis, okay? By looking at my picture, you can see that we hit the x-axis when x equals -1 and when x equals -5. But they're points, okay? -1, 0, -5, 0, because those would be the coordinates of those points right there. Okay. So we're going to do the same thing for this next problem here. Okay. So let's go ahead and do it to it. Part A. Let's find the domain. So guys, just to give you a heads up, the domain is always going to be from negative infinity to positive infinity, okay? The range is the one we have to figure out. So if you notice this graph is opening down, the highest point we have is from 2. So that's telling me that y is going to be smaller than or equal to 2, my range values, right? Or if I'm thinking smaller than or equal to 2, remember, I'm going to start from the bottom and work my way up. That would be from negative infinity to negative 2 if I'm writing it using interval notation. Okay. Now let's do part B. We're going to find the vertex. So remember, the vertex, I'm going to change that first number, negative 3. This one stays the same. Okay. Part C, the equation of my axis. It's the line that cuts the graph directly in half. It's x equals negative 3, right? It's that vertical line. Okay. Part D is in dog. We're going to find the y-intercept. Remember, to find the y-intercept, I'm looking for the point f of 0. So I'm going to put negative 2, 0 plus 3 squared, plus 2. So this is negative 2 times 3 squared, plus 2. Let's see, 3 squared is 9, so negative 2 times 9 plus 2. That's negative 18 plus 2, negative 16. So part D, it's a point, 0 and negative 16. Okay. And then part E says, let's find the x-intercepts. The x-intercepts are going to be these points right here. Okay. So one of them is going to be negative 4, 0, and one will be negative 2, 0. Okay. So let's go on to the next part here. And here it says, given the graph of y equals f of x, answer the following questions. Okay, part A, or the first question here, call it number 1. It says, what's the minimum value of f of x? Okay, the minimum value means we are looking for the lowest point on the graph. Okay, the lowest point is this point right here, but we're looking for the y value. Okay, so the minimum would be f of x equals 3. Okay. All right, now the second question says, for what x value is f of x as small as possible? Now all they're asking me for now is, what is the x value associated with that? We would say when x equals negative 3. Okay. All right, the third question says, how many real solutions are there to the equation f of x equals 1? So guys, just a reminder, f of x means the same thing as y. Okay, so if I were to go here to where y equals 1, here's y equals 1. If I were to draw a horizontal line, what I would then ask you is, I would say, okay, does this graph here hit that line? And we would say, obviously it doesn't. So then it means, so how many real solutions are there? 0 solutions, right? Or 0 real solutions, I should say, because the question is asking me for real solutions. 0 real solutions. Or I might say no real solutions, right? Those two things mean the same thing. Okay. Then question number 4 says, how many real solutions are there to f of x equals 1? So remember what f of x equals 4. Remember what f of x equals 4 means. That means y equals 4. So I'm going to go right here when y equals 4, and if I draw a horizontal line, how many times do we hit it? 2. So we would say 2 real solutions. Okay. All right. So let's go through, we got 6 little problems here. Let's see if we can figure them out. And it says, several graphs of the quadratic equation f of x equals ax squared plus bx plus c are shown below. For the given restrictions on a, b, and c, select the corresponding graph from parts a through f. Okay, and it says, hint, use the discriminant. So again, just a quick recap. The discriminant is this number right here, okay? When the discriminant is greater than 0, meaning it's positive, we're going to have two solutions, okay? That means we're going to have two x-intercepts. When b squared minus 4ac is equal to 0, we're just going to have one x-intercept. And when b squared minus 4ac, is less than 0, we're not going to have any x-intercepts, okay? All right, so first thing is no x-intercepts. So if you look at graphs A and D don't have any x-intercepts. That means that they're less than 0, okay? So that means that, look, this one here less than 0, and this one here less than 0. So if you look at 43, 43 is telling me that A is less than 0, meaning A is negative. When it's negative, the graph opens down. So this one here is going to be 43. In 42, A is positive, which is the graph opens up. This one here has to be 42. Okay, so we got that one done. Okay, now let's look at this one here, one x-intercept. So if I look at graphs B and E, those have one x-intercept, right? Because it hits the x-axis right here and right here. Okay, so equal 0 will be either 41 or 46. Okay, so look at 41. 41 says A is less than 0. A is negative. If it's negative, the graph opens down. So that one's got to be 41. 46 says A is positive. The graph opens up. So this one here is going to be 46. Okay. All right. So now, when it's positive, we're going to have two x-intercepts. So if you look here, we have two x-intercepts, okay? Because it hits the x-axis twice in both cases. All right, so this is going to be either 45 or it's going to be 44, okay? So in 45, it's telling me that A is positive. That means the graph opens up. So this one here will be 45. Here it tells me A is negative, so the graph opens down. This one here is going to be 44, all right? And that's how I'm able to kind of figure out which one matches with which, all right? Okay, so we're almost done here. It says find the equation of the parabola in vertex form with the given graphs. All right, so let's see if we can't do this. So look what it says. We're going to find the equation of the parabola in vertex form. So the first thing I want to do is I want to write out my equation. That's the equation of my parabola in vertex form, okay? So when I look at this here, here's my h and here's my k. So my h is the number 2, my number k is the number -1. So I'm going to write f of x equals, I still don't know what a is, that's okay, x minus h we said was 2 squared, k was the number -1, okay? Now we also have a point right here. Okay. Oops. All right, so we also have a point right here. The coordinates of that point are 0, 0. So this means x is 0, and this means y is 0. Now, guys, I want to remind you of something, that y and f of x are really the same thing. So right here, I'm going to put in the number 0 equals a. Right here where the x is, I'm also going to put the number 0 minus 2 squared minus 1. And now the only thing I need to do is solve this equation for the letter a. Okay, so look, 0 equals a. 0 minus 2, -2, squared minus 1. 0 equals, remember, -2 squared means a -2 times another -2. 4a minus 1. I'm going to bring this 1 over this way. So that means that 1's going to become positive. And my last step is to divide everything by 4. So we get a is 1/4. Okay. So now we're going to go ahead and write out our equation. This is the equation I'm going to write out now, okay? So I'm going to write it out right here. F of x equals A. We just found A to be the number 1/4. Oops, come on, pen. There we go. 1/4 x minus 2 squared minus 1. This is what we're looking for, okay? So when we're going to write the equation, we're going to use the vertex that we have. We're going to use the other point, like this one here that we have. We're going to plug those points in so that we can first solve for the letter A. And then once we solve for A, all we're going to do is come back to this form, really, and just replace that value of A. Okay? Notice something here, guys. This graph was opening upward. That tells me that my number A should be positive, and it was. Okay? Let's do the same thing here for this next one. So first thing I'm going to do, I'm going to write out my general form. Okay? All right. So here's my vertex. So my H is -2. My K is +3. So f of x equals A, x minus -2 squared, and K is +3. So guys, the one thing I know is minus makes it plus, so we can just do that. Okay. Then the other piece of information we have is we know the coordinates of this point here being the point 0, -1. Remember, that's my x and that's my y. Remember, y is the same thing as f of x. So right here, I'm going to write in my number -1 equals A. X is the number 0 plus 2 squared plus 3. Okay. So -1 equals A. 0 plus 2 is 2 squared plus 3. So -1 equals 2 squared is 4. So that's 4A plus 3. So -3 minus 3. This gives me -4 equals 4A. So when I divide both sides by 4, I'm coming up with A equals -1. Okay. So now remember what it is we're going to do. We're going to take this equation right here. We're going to write it out. F of x equals A. We just found that to be -1. X plus 2 squared plus 3. Look at my number A, -1, and our graph is opening downward, right? Okay. All right, so I got a couple more here. Let's do them exactly the same way. Okay. F of x equals A, x minus h squared plus k. So remember, here's my vertex, my h and k. So my h is 1 and my k is 4. So f of x equals A, x minus 1 squared plus 4. Here is another point that we have on our graph, right? So my x comma y is 0 and 2. So the 2 is going to go here. X is 0, minus 1 squared plus 4. Okay. So 0 minus 1 is a -1 squared plus 4. Remember, -1 squared is just 1a plus 4. So I'm going to go -4 and -4. So 2 minus 4 is a -2 equals A. All right. So now let's go ahead and write out our equation. Remember, I'm going to use this form right here, just filling in my number A. F of x equals a -2, x minus 1 squared plus 4. Again, look at my A number. A ended up being negative, and our graph is opening downward. Okay. All right, let's try this next one. Again, exactly the same way, right? So f of x equals A, x minus h squared plus k. Okay. All right. So our vertex here, my h is -1, my k is -12. So f of x equals a x minus a -1 squared minus 12. Remember, this becomes plus. Okay. Here's a random point on our line, 1, 0. So this is x and this is y. So 0 equals a 1 plus 11 squared minus 12. Oops. So 0 equals a 1 plus 11 is 12 minus 12. Okay. 12 squared is 144a minus 12. So I bring that 12 over, so that's 12 equals 144a. So when we divide both sides by 144, a is a positive 1/12. So now I'm going to take this form right here. I'm going to write it out right here. F of x equals 1/12 x plus 11 squared minus 12. Okay. And here is my equation. All right. So got another little part here, and it says human cannonball. So let's see, these are the times and dates, but let's see if we can read this piece right here. It says, as the countdown begins, David Smith Jr., the bullet, dons his safety helmet, slides down the slender barrel of a cannon, position himself to become a human projectile. The crowd joins in the countdown, and the announcer asks the audience to cover the ears for protection from the noise of the blast. 3, 2, 1, fire. David Smith Jr. blasts into the air, flies an average distance of 160 feet and a height of 60 to 70 feet, lands in his pre-positioned safety. What we're going to do, guys, we're going to find the equation of this human cannonball. Okay. So we know how far he went. He went a distance of 160 feet. So if he started here, ended up here, we know that that distance there is 160. We also know, okay, thinking about this as kind of like my x-axis and my y-axis, okay? We also know that he reached a height of, we're going to say 70 feet. Okay. So that's 70 feet right there. Okay. Let's think about this as a parabola. Okay, so here's my vertex, right? So this here would be the point 160, 70. Okay. Oh, no, I'm sorry, not 160. 160 is the entire distance, right? So the entire distance is 160 feet. Then halfway would be 80. So let me fix that right here. There we go. That's going to be 80, right? Because that vertex is going to be right in the middle. Okay, so look, we're going to write out the equation. F of x equals a x minus h squared plus k. Okay. F of x, so I'm going to do this just like we've been doing before. X minus 80 squared plus 70. Now remember, I got to find another point. Well, this point here would be the point 0, 0. And this point over here, if I wanted to use it, would be the point 160, 0. Okay. I'm going to use 0, 0 just because it's an easier number to plug in. Okay. All right. So I'm going to put 0 here equals a 0 minus 80 squared plus 70. Okay. So let me scroll down just a little bit so I have enough room. So 0 equals a 0 minus 80 is a negative 80 squared plus 70. Okay. So 0 equals a negative 80 squared should be 6,400 plus 70. I'm going to move this 70 this way. It becomes a negative. Oops, there we go. Equals 6,400a. So when I divide both sides by 6,400, okay, Get rid of those zeros. I'm coming up with A is a negative 7 over 640. Okay? So now I'm going to write out the equation. F of x equals A, negative 7 over 640, x minus 80 squared plus 70, right? And let me show you one more thing. So you might ask, how does one become a, or what does a human cannonball look like? So here it is. And this is the guy, David Smith, and they call him David the Bullet Smith, and this is his Guinness Book of World Records. All right, so if you want to know how does one become a human cannonball, well, because your dad's a human cannonball. So this is the same guy, but it's his dad.
Welcome to America.
Yeah.
How was
Got
that
my
jump,
passport.
sir? You have your passport with you?
Yeah, I carried everything.
How was the jump?
Good. Piece of cake.
Was it what you expected?
Yeah, it's easy. It's all right.
By this time, did you find out what was going on? Why did you jump?
For money. I get paid.
All right, so anyway, that right there, guys, he was being shot across the border from San Diego, California into Tijuana or back or vice versa. I don't remember exactly what it was. Anyway, that is 3.1.